This didactic material is meant for the personal use of the student only and is copyrighted. Its reproduction, even for a partial utilization, is strictly forbidden in compliance with and in force of the law on the author's rights.
Hello, my name is Massimiliano Schiraldi, and this is the course of Operations and Service Management. This is the fourth lesson. We'll see the inventory build-up diagram, so we'll see in details how the inventory level changes as varying the input and the output in the warehouse, in the storage point. We are going to remove Wilson's unrealistic assumption, the simplistic assumption of Wilson model we've seen in the previous lesson, and determine the size of the safety stock. Specifically, we're going to remove the assumption of constant demand. We're going to add the assumption that the demand is stochastically distributed. And then we're going to introduce the virtual safety stock, which is a difficult concept, but very interesting concept. First of all, let's start with the inventory build-up diagram. This case is a didactical case and quite simple, so we should not have any problem in passing through it. Let's imagine that we have a warehouse of a factory in which raw materials are received with different rates in each period of the year. We'll analyze two graphs. This type of graph is the graph which describes input and output rate. That means the rates in which the inventory is filled and which the inventory is depleted. And the graph which is in the lower part of the slide will describe the inventory level, how it changes. So this is a method. The first one is a matter of dynamic fluxes. So how this is described the transportation inbound and outbound the inventory, and this second graph describes a static situation. It means the change that makes only depict only the level, means the quantities in the inventory, not the quantities per time. Okay. Let's imagine that this is the first warehouse of raw materials. Okay, raw materials that feed a workstation, a factory, which can be modeled like a workstation, and this workstation has a production rate, a constant production rate, which is 3,000 tons per month. So the production rate of the machine, which is downstream of the inventory, is the output rate from the inventory, because it's the rate which the materials are getting out from the inventory, and is described by this dotted line. Okay, the black dotted line is the output rate from the inventory, while the blue line is the input rate. And imagine that we have the seasonable raw materials. Let's imagine that these raw materials are entering the inventory with three different rates. For the first 4 months, they enter at the 3,600 tons per month. Second period of time, they enter at 4,800 tons per month, and the third period of time, they would enter at 600 tons per month. You see, in this case, the variable input to the inventory, the input in inventory is variable. So the inventory is very important and needed in order to decouple the dynamic of the filling of the inventory and the depletion of the stock levels. The computation are written on the right side of the slide. So we see that month 0 to 4, we are starting inventory level is 0. The input rate is 3,600 tons per month. The output rate is 3,000, so the net input rate is 600 tons per month. So after 4 months, we have an inventory closing level of 2,400 tons, which is right here, because the inventory is going to grow with this rate, and the growth rate is 600 tons per month, which is written here. From the month 4 to the month 8, so we are in the middle period, the starting inventory level, of course, is 2,400, which is the closing inventory level of the previous time interval. The input rate is 4,800. You see is this higher input rate here. The output rate is always the same because it's always the production capacity of the downstream machine. So the net input rate is 1,800 tons per month. So the inventory is continuing growing, and you see it grows up to 9,600 tons, which is the sum of 2,400, which was the initial inventory level, and 1,800 times 4 months, which is the net input rate multiplied by the time interval. In the last 4 months, month 8 to 12, so the starting inventory level is 9,600, which is this point, the spike in the inventory build-up diagram. The net input rate is very low, is 600 tons per month, so it is not enough to cover a production rate of 3,000 tons per month, but being the presence of the inventory, we can ensure, we can grant anyway the output rate of 3,000 per month, of course depleting our inventory with a rate which is minus 2,400 tons per month and going back to zero at the end of the time interval. So in this way we manage to feed the production system, so to ensure the production capacity, the production rate to 3,000 tons per month thanks to the inventory. The average inventory level, if we make the computation on the average of this inventory, which is almost in this height, is 4,000 tons, and the total production is 3,000 tons per month times 12 months, so 36,000 tons all over the year.